have to remember to wear a hair tie. Okay, starting with the day one summary. Again, there is something there's 2 slides, so if you don't see something on these 2 slides, please let me know. We'll go ahead and add it to the list. So for day one of the first items that we came up with is a set of candidate GM models broad enough to capture the full range? Is there a credible method applicable to DC, PP, or PBNGS, TDI that would give very different results, and what are we missing? And then the term slap-down phase was introduced, which was sort of a little bit new to us.
That's Tom
new to me.
Tom Heaton's comment that we need to be broadly thinking, is there some other approach that we haven't captured? Normally that's a explosion phase, right? But go ahead.
One comment about it. That's the kind of thing that...
Sorry, can you use the microphone? As a reminder, we have been recorded. There are people online listening to us. We are GoToMeeting, so it's important to use the microphones to state questions. State your name as well. Thanks.
Gabriel Toro, the comment about is that the slap-down phase and similar wave propagation issues fit very well within the aleatory uncertainty. And so at some point, we may put it there and not worry anymore about it.
The point here is just for us to be sure we haven't missed something. So if our aleatory captures it, we can say we've got it there.
Okay.
Okay. John Stewart had a question.
Sorry. Can you just define what you mean by slapdown phase? I don't know what this term means.
I'm not entirely sure either. It sounds like a wrestling term, but I don't think that's what we're referring to.
The ground goes up and comes down wham, like that, okay? So, and you may get this on a reverse fault. Brune used to talk about them with his foam rubber models, and the tip would fly up and come back down again, okay? It's just a normal thing that we might not have, but it would be contributing to the tails of the distribution that Gabe was talking about. Say that again? And it's been observed in earthquakes, as Steve had said. So this isn't made up, this happens.
Okay. Next item is to extend the hazard out to 5 seconds. Part B, it was requested that for small magnitudes, the M5.5, there is an elevated long period motion, or actually to look at Part B, because what we found in talking with Kim Olson is that for the 5.5, that doesn't look like that's necessarily an issue, so maybe run a couple new Part B simulations.
So this is really to help us get at our evaluation of the rupture generator. You know, what's causing that discrepancy between the empirical models or the data and then the long period simulations? And if it's not happening at magnitude 5, then 5.5, then why is it happening at the larger magnitudes? Is it something physical that we should be following? We're back to which models are right type of a question.
Okay.
Go ahead.
Next is to check the new CyberShake, the magnitude 8 for the long periods. Kim also, whenever he was showing his plots, showed some of the short periods. So we're also looking at, okay, what does it look like in the long periods? We'd like to see some of that and compare those with the 1D calculations to see how they match up. I need to correct the ASB plots for the hanging wall. SDSU plots for Cho and Young's 08. You were plotting it against our RUP, and it looked a little bit strange, so we'd just like to sit down with you for the Cho and Young's when you're looking at the different depths. So maybe taking a look at that as well. Tom Heaton had brought up consider the asymmetry distributions for the epistemic uncertainty.
That's not
no, that wasn't Tom Heaton.
Bob Budnitz.
Yeah, that's right. Thank you. I have all the names on my other sheet. Also looking at aleatory variability for hanging wall sites using the finite fault simulations. And you guys can read, so I don't.
So this was Adrian's comment, can we see a difference in aleatory variability? And the only way to get at it is with simulations. But we don't trust our absolute numbers, but maybe the relative numbers will be useful for us.
Right. So I'm going to be normalizing those here pretty shortly. Also for the finite fault simulations at long periods with t greater than 3, summarize the surface slip distributions. We had a good discussion on that yesterday. Also check that the peak displacements of the simulations are consistent with the surface slip.
This was again Tom Heaton's comment of making some way to just check that everything is making sense.
One of the items that I'm going to have, just I talked about it a minute ago, is to normalize the hanging wall scaling. Basically, just normalize it at an RX of -10 and see not necessarily the absolute amplitudes, but how they compare to each other. And then also the hanging wall effects for the magnitude 5.5. We are considering if there's a radiation pattern for more deterministic at higher frequencies. And does this depict the applicability of the finite fall simulations down to 5.5, near about 5 hertz? So are there any other comments or issues that we need to add to the list of things that we need to review after the workshop?
Especially anyone who made a comment, if you think we haven't captured something that you said that is an important piece we need to deal with. No.
Okay, thank you.
Jennifer.